Morning everyone, hopefully everyone can hear me okay. I think we pretty much have everybody on who will be on, so we'll get started. Firstly, welcome and thank you for attending this webinar. This is the second in our series of webinars that we're going to run around test automation. This morning we'll be following on from the last webinar and we'll be looking at the considerations around how automation should be applied in an environment where there are multiple applications that require automation. And crucially, how this varies from the commonly defined happy path approach that you see, where you have a single app to automate, and often in this case, the app is developed internally and you have control of the build process. Whilst the approach is different, the key benefits, the challenges, the ROI case, everything that I talked about last time, that still exists and that still applies. So we're going to be looking at a number of different scenarios and a number of different approaches. There's also a couple of short demo videos that show examples of how to do this with various tools. Moving forward, we have a few options on where the other webinars in the series could go. So as ever, we'd like to hear feedback from you around what's important to you and what you'd like to see, then we can steer down this path. A little bit about me, I'm Ash, one of the co-founders of Ten10, with my background in hardware and software engineering, development and architecture, with experience in technical testing and designing testing solutions for clients. Just like all the other webinars we've done, if you missed something today, or you want to review something or catch up again, this webinar will be available to stream in your own time. So if you do miss something, you can catch up. And finally, just one more point, if you have a question as we're going along, please enter it in the chat window in the GoToWebinar control panel on the right hand side, and we'll try and answer as many as possible at the end today. If we can't answer them on the call, then we'll respond back to you individually. So last time we looked at a general approach to automation and choosing the right approach in order to maximize ROI. So this time we're going to drill into some of those different scenarios for automation where the requirements are a little bit different to that happy path. So as I mentioned, there is lots of information around there on the web around automating apps, but a lot of it's focused around automation of a single product in a single technology stack, and how automated GUI tests in that environment can be used to accelerate regression testing. When that happens using that sort of single tool approach, the automation approach and the tooling selected, it's often tightly coupled to the particular technology that the app's written in. Sometimes that requires changes to the build and release process to make the application work well with a chosen automation tool. So that approach works well in an environment where you have control of the build process and you have access to the development team. You can try a variety of tools against the app, see how well they work from an ease of automation, maintainability, reliability viewpoint. You make your choice and then you continue writing and maintaining those automation scripts for that application. So that's all fine, so far so good. But what happens if you're not a software company developing a single core product or range of products in a particular technology stack? What happens if you develop many different apps across many different technology stacks, or indeed if you don't develop any of the apps yourselves, but you integrate many different vendor solutions, so you're almost more of a systems integrator? If you recall last time in the webinar, we ran through a couple of scenarios. We had company 1 and company 2. We're just going to revisit that kind of company 2 scenario. So in this case, it's a consumer of 3 different core enterprise applications, 15,000 internal users spread throughout many different countries, but crucially, in excess of 100 different applications deployed to the desktops through that corporate image. They need to perform regression testing against the apps whenever there's an upgrade to either the apps, the operating system, or any middleware components, or any security patches. It will take about 6 man-months to run that full regression test, and the application stacks vary significantly throughout their production estate. So this regression challenge that they see here is the same from a manual test perspective as for the company that may be developing a single app. And the business case for automation is the same. You still like to realize the same benefits of automations of speed, reliability, reduced execution time, but the challenges are different. So we're going to be drilling into that a little bit more across those scenarios. So we also mentioned last time the idea that there's different types of automation. So I'm not going to run over all this again, but largely the tooling falls into two different camps. You've got that kind of object-based and image-based. But if you remember, high-level object-based tools interact with the application through an abstraction layer, a programmatical model that represents the app. And your challenge in automating these apps is in finding, interacting, and checking for changes in controls through this abstraction layer. So you do this by inspecting and modifying various properties of objects and then calling methods on those objects. For instance, myButton.click to click on the button. So by comparison, that image-based approach works by the automation engineer finding a bitmap of something on the screen that they're interested in and storing this in a test script. And when that test script runs, the test tool compares the bitmap that was stored in the script and tries to find that in the application that's on the screen. Once found, it interacts with it through sort of moving the mouse over that, clicking on the buttons, typing text in the keyboard. So conversely, to assert on a particular condition, perhaps to check whether a text box says "Hello Ash," you've got two approaches there. You either use that same bitmap matching approach to find the exact image as text, which obviously isn't advised because then it's hardwired to just finding "Hello Ash," or you kind of suggest whereabouts you think that text might be, and then the app captures the bitmap of the area and uses optical character recognition, OCR techniques, to translate this bitmap into text and to try and map that text to a string so you can assert if the condition is what you're expecting. So both are two very different approaches. They both effectively achieve the same results, but in very different ways. So there are relative pros and cons to both, especially when you're considering automating one app versus automating lots of different ones written using different technologies. So if you're automating a single application, now this on the whole, and this is on the whole, it's not always the case, but on the whole, that object-based approach tends to work best. There's an initial upfront investment in time and effort with all these tools before you can write a single script. And you may need to modify the build process to make the app automatable. You may need to identify various controls and write code structures and abstractions so you can interact with them. So whilst this takes longer to write your first script or small set of scripts, the advantage in this approach is that you quickly make up that time. You're able to reuse those abstractions you've created, speeding up the creation of new scripts. The scripts tend to be more robust and reliable, again, not always, but generally as a rule of thumb. And one thing generally say for sure is that they tend to execute faster than the image-based approach. There's also some fringe benefits to consider if this is applicable to you. So if, for example, you have an application which you actually white label across a large number of different customers, for example, or, for example, if you take that same app and you release it throughout the world in many different languages, if you're careful and you give due consideration to this up front, then you can reuse the same test scripts in those scenarios, even though the app looks completely different, it's white labeled differently, or the app is actually in a different language. We have projects where we are able to reuse the same test scripts across all those assets. So if, for example, you have one app and it's white labeled across 30 different clients and it's released across 30 different languages, that represents an awful lot of regression testing. So there's quite a lot of value in that scenario there. So on the other hand then, if we have that multi-app automation where we have many different apps written in many different technologies, this approach often lends itself better to that image-based view. So this is where that comes into its own. So the difference, one of the key differences, is that it doesn't really require that same upfront front-loading of effort before you can get started. It's flexible, so you can use the same tool pretty much anywhere where it is output to a screen or where it's interacting normally with a keyboard or a mouse or gestures if it's a mobile device. But you can also extend that. We're going to look at a demo in a little while where we're able to take that same tooling and that same approach and extend that into set-top boxes that output on a HDMI connection, which that object-based approach you would really struggle with because the application stack is so different. In this case, you can reuse that. Disadvantages. I mentioned before that idea of if you're trying to assert on a text string, the amount of effort that's required in an object-based approach where you just are doing a string comparison, which is no effort whatsoever, versus if you think the software is having to identify the area of the screen where it thinks the text is, it's then having to take that bitmap, translate that into text, and it's having to do that across a wide variety of different font types, different font sizes, whether it's anti-aliased or not. That requires a lot of processing effort and is less reliable. But that said, I'm always impressed by just how well a lot of these tools do work and how reliable they are in terms of being able to recognize and read back text. And they have actually got a lot better recently. But it will take significantly longer than just doing a string compare. Additionally, you have the scripts that are susceptible to visual changes. So we had a scenario where we were using an image-based approach, and what it turned out was that the way the app was written, a significant amount of actually how the bitmaps and how the app was actually viewed on the screen wasn't actually done in software. It was actually offloaded to the hardware, the GPU, the graphics card. And so when you switched hardware platforms, that varied slightly. So suddenly the app didn't look quite the same. To a person it did, but when you're comparing bitmap images, there were some issues there. So for example, that's another one that can bite you. And the fact that as a result of the OCR, as a result of just the fact that it's having to take that image, it's having to find and match bitmaps on that image, it is slower to execute. But the biggest benefit here is that it is, obviously nothing's completely future-proof, but it is largely future-proof as a result of the fact that as long as you can see an image on the screen and as long as you can interact with that image through keyboard, mouse, gestures, whatever else it is, you're able to automate it, then that's the most compelling reason if you have lots of different apps that you want to automate. So that's fine then, in that we've looked at these two kind of scenarios, which are really kind of at the two extremes. And as ever, things aren't always black and white, there's kind of shades of grey. So in that single app environment developed internally, you're able to modify the build process. It does make sense to use a single object-based tool. On the other end, at the other end of the scale, as we just described there, if you have multi-app with many applications, differing tool stacks, it makes sense to go for that single image-based tool, not object-based tools I've written there. But let's just think about some of the scenarios kind of in the middle here. So for example, one scenario we come across quite regularly is that you may have a single app which is responsible for kind of 90% of the functionality that your users are doing, with a wide variety of other apps making up that 10%. So on the basis of that, you may think, well, it's a multi-app scenario. There are many different applications involved here, so clearly that's a case for image-based automation. But what we find, and I mean, there's a good example of this in particular sectors. So for example, we work quite a lot in the legal sector. There's a practice management system used in the legal sector, which is very prominent. It's developed by Thomson Reuters. It's called 3E. That 3E client is written in Silverlight. Now, Silverlight isn't the easiest technology to automate, nor is it supported by many different tools that are out there. But there are tools that do support it. There are tools that do work with it. And one of the best ones we've found to do that actually is Ranorex. And we've tried a few different approaches over the years, but that one seems to work best for us. So in that example, that's maybe a good example of this two tool strategy, where we say we'll use a tool, an object-based tool, to be able to automate 90% of the scripts that need to go on there, because we like the fact that we get the benefits of the faster script development, the low maintenance overhead, and all the other benefits you get from an object-based tool. But then we use an image-based tool to wrap up all the other tens or even hundreds of different applications, maybe where the test script starts in one app, it then goes into the main app, and then maybe it ends up in finalized in a different application. Being able to use a two-tool strategy to pull all that together is quite advantageous, and you kind of get the best of both worlds, really. One key point here is that we do use Ranorex for this approach. Ranorex actually does a little bit of both. It's object-based and it can do the image matching stuff as well. So that's quite a good example of where you can just use a single tool but across both different types. The second example I want to just look at here is and think about is a case where you have the same application but deployed across multiple different platforms. So in this example here, I may be thinking about iOS and Android smartphones. So native apps running on iOS and Android. So although the app looks roughly the same and it has the same functionality, often, not always, but often the way that the tool stack that's used for creating native and iOS and Android applications is completely different. So we could potentially use an image-based tool here. It would work. But on reflection, in this case, in this example, if we think that we have access to the build process, to the development teams, to the source code for both tools, so in reality, that would make more sense to use an object-based approach. And in this example I'm thinking of here, we ended up using Appium. So that's an open source object-based automation tool that uses the Selenium WebDriver API and wire format under the bonnet to work, and that worked well. So that was using Appium with a generic framework integrated and executed from Jenkins that could run on real devices, but can also be extended to run on cloud-based mobile providers to give you that device coverage across different devices, OS versions, etc. So this particular example, I was thinking about, we've got a video demo, but I was thinking about running that up today, but in fact, to do it justice, it's going to be about 30 minutes long. So really it's a webinar in its own right, so I think we will continue that in another webinar. But in practice, how we're doing it is it's a set of Appium tests, common tests, with a set of page objects, and within those page objects, we're using the different selectors for both the iOS and Android controls. And so we're able to use both of those within a single script. So scenario 3, and this is straying off the happy path again here. So what happens if you have the same application running on many different platforms? But what happens if these platforms aren't just desktop, mobile, tablet? What happens if they're actually set-top boxes, if they're games consoles, or if it's a smart TV, for example? Completely different application stacks with a far wider degree of variety than you'd find between, say, iOS and Android native apps. And also, you've got the challenge that the input device probably isn't a keyboard or a mouse, but in fact might be an infrared remote control or something similar. So there are approaches that will work with this too, and I will show you a little video demo of those in a couple of minutes. Okay, so I will now just play you that first demo.
This is a screen recording by Ten10 detailing Microsoft Word and Microsoft PowerPoint using Ranorex. For this demonstration, we have recorded 2 test scripts. One was a test script against Microsoft Word, and another one was one written against Microsoft PowerPoint. Just to quickly run through the scripts. The first step we do in both tests is to open the relevant applications. So if I run through Word first, we open up Microsoft Word. Then what we do is we create a new document using the Ten10 template. And then once that document has been created, we will go in there and validate that the Ten10 footer is in the document and indeed that it is correct. Following this, we will actually save documents to the hard disk. And what we will actually do then to demonstrate we can interact with Windows Explorer is to open up Windows Explorer and validate that the file does exist where we saved it. And indeed we'll do some sorting by date modified descending so that we can see that it is the most recent document in there. The final step will be to close Windows Explorer, so we will be left on the Microsoft Word screen. Very similarly in PowerPoint, we open up PowerPoint and then we create a blank presentation. The next couple of steps are validation steps. So we wanted to look at verifying that, for example, all of the tabs are displayed in PowerPoint. These are the ribbons that you see at the top of Microsoft PowerPoint. And indeed, the next step there is to validate that the home ribbon is selected. Then we carry on to actually edit the document. So we change the layout settings in PowerPoint to be title only for this particular slide. We then actually edit the title of the slide. We add an image, and similarly to Word, we save that document to the hard drive and ultimately validate that it exists. All of these test steps here are actually written as modules, so they can be used across tests. And indeed, you can see that, for example, Launch Windows Explorer is present in both the Word test and also the PowerPoint test. So we only had to write this module once, and we could reuse it in both test cases. Similarly, the other interactions with Windows Explorer are also modules, and so they were only written once and then reused. Finishing the script off, we then close Windows Explorer to leave us back in the PowerPoint screen. And at the end here, we do an image comparison. This will actually fail when we come to run the test script. It's a deliberate failure. I have forced it to fail so that we can take a look at what the errors in Ranorex look like and what kind of a test log looks like. So Ranorex itself is actually a very friendly tool for both technical and non-technical users. It gives the capability of writing scripts as kind of keyword in a kind of keyword-driven way. So it will, for example, in this Save As module, say click on the File tab button here, and actually over on the right here you get a screenshot of what it clicked when you do the recording. I'll touch on that in just a minute. Similarly, down here you can do other clicks, get values. There's various actions that you can do down here, such as insert text. You can do some validations. If this was running on a mobile device, you could do touch and swipe gestures. And then further to this, you can actually execute some user code within Ranorex. So when I was saving my documents, I wanted to append a timestamp to the documents, as I did not want to get a situation where I had to overwrite documents or anything like that. So what we can actually do there is write some user code. So this is actually getting a bit more technical, and Ranorex allows us to write code in both C# and VB.NET. So actually down here you can see that this is a method for enter file name, and what it will actually do is generate date and time in a year, month, etc. format, and it will put that text into the save dialog. Similarly, actually all of these modules can be written as code. So if we view the code, for instance, for this module, there's actually very little in it, but what you can do is convert the recording into a code module, and then you have kind of full control and the full power of C# behind you in case you need to do complex interactions with the application or some kind of calculation or other that Ranorex doesn't provide in the UI. So in general, Ranorex is very powerful. It can be used to write very simple scripts by non-technical users. As I touched on earlier, there is a point-and-click record functionality. So that is via this record button. And effectively, you can click that and you can click through your applications. So I can open up Windows Explorer here, and I can navigate to various different areas here. Script, so I can delete that. So taking this forward, we could actually, what I think I'll do is I'll run these scripts to show you them running. I promise that my hands are nowhere near the mouse or keyboard when I'm running this, and in fact in the bottom right of the screen you will actually see a Ranorex running window that will detail what is happening at each stage. So I'm going to go ahead and click run, and I might talk through as various actions happen. So initially, Ranorex launches because we're using the evaluation version. We get this pop-up. So it's not quite fully automated in the evaluation version, but rest assured, when you have a license for Ranorex, it's not being displayed. So we run the word test first, and what it's doing here is selecting the 1010 word template. It's already gone to the second page and validated the footer. It's now putting a file name in there. The text input is actually quite slow here, but that can be sped up. We are now validating this in Windows Explorer, and we can see the document was there and it was comparing it. And now we've moved on to our second script, which is PowerPoint, and we're already going into add title to this document. And we're going to insert an image, and then we're going to save the document, and this is actually where I've added the timestamp functionality. And again, similar to the Word script, we are going to check that document does indeed exist and was created correctly, which it has, and then the test script has finished. So immediately after a test script is finished, this is the screen that will be displayed to you. As we can see here, the word test script passed. It's got a nice big green tick next to it. If you wanted to, you can come in here and see exactly what the script did. And there's all sorts of timings as to how long things took, and various different information in here going down to the low level of what actually happened, so you can see where it clicked and where it clicked. The more interesting case down here is the PowerPoint test. So we'll see that everything passed in here, except when we get down to the compare image. Now what I actually did was I selected an image from the disk that was deliberately incorrect. So what I did is I selected, put into the document the image at the bottom here, but actually what I was expecting was the nice 1010 logo here to be displayed. So we actually used Ranorex's image-based comparison capability to check that that was correct. So this was not done based on file name or any other properties. It was a image-to-image match, and it identified that this image that it found in the document was indeed different to this one, and therefore failed the test script. That is an introduction to Ranorex. It's by nature a very modular application. So actually in this RX rep file, which is Ranorex's repository, we can see where Ranorex itself stores objects. So for example, we can take a look in the word menu here, and we have an element here called the personal tab. So this is when we were going in to select our 1010 template. We first had to click the personal tab, and then we had to select the template. And indeed down here you can see where it's selected, the 1010 template. So once these elements are added to the repository, they are reusable across all test scripts. I believe that is everything that we might want to cover. I'm sure there might be questions that come up from this, but indeed I'm sure they can be answered as and when necessary. Thank you very much.
Okay, so that was Office. Automating Office is actually pretty tricky, we found as well. Automating the controls within Office is pretty tricky. Automating document creation, reading things in documents that have been created by people and organizations is even harder. But Ranorex does cope well with that kind of thing. We had a question come in, somebody just asked whether that was object-based or image-based. It was a bit of both. It's obviously the image matching that we described there, that's based on matching an image. But if you relook at the video again, what you'll see is that when it was identifying applications and it was finding those tabs in Word, it was using object-based, so there were things like automation IDs in there, there were process names in there, so data that it was using internally to work out what applications were, what controls were within those applications. So just going to have a little look at another demo now, that third one that I described before, which is something very different, where you don't have, where you have similar apps but across very, very different technology stacks. And this is using a tool called Eggplant, which is solely image matching. So in this case here, what you can see in the top right is the actual physical device itself that's been automated. You can see the eggplant scripts there, and what you can see in the right-hand side, in the bottom right, is actually the viewer that eggplant has into the actual device that's been automated itself. So we can see there that for example, we're clicking on images, the various images that we're looking to find. We can see that we're typing in the username, we're typing in the password, and that now the images are playing, the adverts are playing there, and we're able to see in the log that the ads are running. So now we're extending this a little bit, and this is now running, very similar thing, but running on iOS. So iOS has some more complexities, I'd say, than Android in terms of automation. There are more restrictions around how you're able to automate it. One good thing that Eggplant has going for it is that if you don't have access to the source code or access to that build process in any way, if you can deploy the app on a phone, on an iOS device, then Eggplant will allow you to automate it without you having to jailbreak that device or do anything else to it. There we go. So that's a very similar application that we're seeing there. So the next example that we're going to look at in a second actually relates to us moving away from us having just a device there, a mobile device. This is Apple TV. And what we're actually doing here is the main image you can see there is us viewing the Apple TV main screen, the HDMI output as it's running. But what we're actually automating the iOS Apple TV application in the bottom right there, so you can see that's running, and you can see that as we're clicking on that, we're actually moving around and navigating around Apple TV. One thing to note here is that things are a little bit slower, particularly as you saw there where we were playing video. It does take quite a while, and there can be a bit of a lag between what's actually happening on the device and what's actually happening on Eggplant's viewer and Eggplant's ability to interact with it. So that's just one thing to watch. One other challenge that you often have with these set-top boxes is around HDCP, so high definition content protection. So HDCP essentially stops you from being able to view the output on something which isn't actually a sort of registered endpoint, so perhaps a suitable TV or something similar. So that can be a bit of a pain when it comes to automating these kind of devices. There's a little trick that you can play here if you're ever stuck in that scenario. If you're familiar with the idea of a HDMI splitter, which is where you have a single HDMI cable running into a small box, which allows you to split that HDMI signal to a number of different TVs, for example. Not all of them, but some of those splitters, as a result of it splitting that HDMI signal, one of the side effects is it can actually strip off the HDCP, the content protection as well. And that's indeed what we're doing here. So there's the Roku device that we're actually testing that you can see there. All of that is HDCP protected. So if you actually plug that in without the little HDMI splitter there, you wouldn't be able to see anything, so you wouldn't be able to automate it. One of the other interesting things about this is that if you can see in the top right there, what we have is an infrared transceiver. So that infrared transceiver, that USB infrared transceiver, is used to record the signals from the Roku infrared remote control. It captures those, and then there's some various open source software that you can use to replay those codes through that infrared transceiver, acting as a transmitter in this case, and that goes into the actual Roku device itself. So that's what's used to control it. So you can see that happening there. I'm afraid it's a little bit untidy in the top window there, but that was just to illustrate kind of how it works essentially. So as you can see, it's pretty versatile, and it does kind of allow you to, as we mentioned earlier, kind of work with pretty much anything where you kind of have a means of controlling a device and a means of displaying it on a HDMI output. Okay, so that's kind of it for the demos, really. But what I want to do is just kind of bring it back to the point that while some of the tools and techniques that we're looking at here are maybe a little bit different than some of the approaches to some of the mainstream ones, the same principles still apply when it comes to planning your automation, when it comes to having those robust manual test assets in place in the first place, which are created in the right technique so they're able to be automatable. And that point I made last time around in terms of calculating your ROI, in terms of calculating the number of scripts that you have in each, number of steps in each script, is a little bit more complex because if you have multiple tools, you'll find that you have a different step time across each of those tools, so that needs to be considered. And also you'll find that the percentage rework, the maintenance overhead that's required between scripts will vary across each tool as well. So if you have a number of tools, you'll just find yourself repeating that effort in terms of the analysis and the forecasting and the understanding of how much work's required. Ditto that variability of step time. What we find is that with object-based tools, you'll be progressing at quite a rate of knots until you will find some control where it's difficult to find it, maybe it's difficult to interact with it, it's difficult to control it, or you may find it works 90% of the time, but then 10% of the time it doesn't work. That's often the kind of thing that slows you down with those object-based tools. The image-based tool, you don't tend to find that variability in terms of interacting with it. You just find it on the screen and away you go. But reliability can still be an issue. You can have sort of race conditions between waiting for things to appear and synchronization issues, particularly as it takes, as we saw there, it can take quite a lot longer to run those kind of tests. If you think about the relative speed that we saw between the Ranorex tests that were running there that were largely object-based and the eggplant tests that we saw there that were wholly image-based. But again, ultimately, you're still calculating the number of executions that you think you're going to need, and you're actually working out that return on investment in terms of how much you need to invest and what you're going to get back from it. So in terms of just some tips to kind of get you started then. So one thing I think I mentioned last time is that the tool is really just a means to an end. And if you find yourself in this scenario where you're using a composite of different tools, then this is more important than ever. And what you want to be doing is to look to use common tools for execution, reporting, for management of those scripts. And this is particularly the case where you have scenarios where the test script starts in one application which has been tested by one tool. It then moves across to another application which has been tested by another tool, and then maybe ends up somewhere else which is tested by yet another tool. That kind of execution there, that allows you to maintain state of those tests across the different applications and pull it all together. So open source wise, we generally use Jenkins for that role. It tends to be pretty extensible. It's commonly used. There tends to be plugins for pretty much everything. And then you just have one common set of reports, one common set of dashboards, which just makes it easier to explain to users what's actually going on there. You know, they don't want to be bogged down or have to worry about whether this app has been tested in tool Y or tool Z or tool A or tool B. They just want to know how the whole thing looks across the board. And so tools like Jenkins, they have pretty common ways of you being able to output from those tools, from the test tools, from you being able to pass parameters into them, and that makes the whole thing pretty seamless, really. Consider the relative usage of different apps. Don't just think about the fact you've got 10 apps. If you have 90% of the work and the test script effort is going on in one app, then think of it as one large app and a few other apps doing everything else, and base your priority and how much you invest relative to the different tools, relative to the different applications with that in mind. So yeah, consider more than one tool. Not always the best idea, but often often can be. One common anti-pattern we see is where people are trying to use one tool and they're trying to shoehorn all kinds of things into it that it was never really designed to do, or it just doesn't work well with it. If that's a scenario, then as part of that proof of concept, you really want to kind of cut your losses and say, you know what, one tool isn't going to work. We need to think about a number of different tools in this scenario. So I think I've covered that one. Consider execution time. As we've seen, those image-based tools, not always, but generally are slower to execute than the object-based ones. There are things you can do. You can have multiple sort of build slaves running, multiple across different physical devices, across virtual devices, across cloud-based devices. So you can parallel up that activity, but you just need to be mindful of any data that might be used across different tests, synchronizing that to make sure that you're not having a test changing data that another test is trying to use at the same time. Need to think about hardware in terms of how many slaves you're using to execute those tests on, and if it's a commercial tool, you need to think about licensing as well in order to do that. And finally, just as I said last time, we talked about GUI automation here. This is where a lot of the focus is, but if possible, if you can automate at a lower level than the GUI, then do so. Because what's a definite certainty is that automating at a lower level than the GUI will be orders of magnitude faster than we've seen here today, even for the object-based ones. Okay, so I think we're kind of coming up on time. I think we've got a couple of minutes left. But let me just have a look here and just see what any of the questions we've had coming in. The only one I can see is the one around RunnerX that we saw there earlier on. Was it object-based, was it image-based? I think I said that was it was a bit of both, and it can do both. And as a result of being able to do both, it's quite compelling in certain scenarios. Okay, so that's all I wanted to run through today. I think our current next plan is we're probably going to pull together a webinar running through that scenario 2 that I mentioned around the same app on iOS and Android and using Jenkins, Appium, probably browser stack, just to sort of demonstrate how all that ties together and how all that works. So that'll probably be the next one. But if anybody has a strong view of what they'd like to see next, let us know, and then we're able to change that according to what you need. So I think it just remains me to say thanks very much. I hope that was useful to you, and just to enjoy the rest of your day. So thanks very much. Thank you.